All right, today we're going to take a look at the geometry questions from the ACT, specifically from the homework. I'm going to check and see if this calculator app is going to work out the way I hope. See if this is going to show up, just checking it out. All right, let's see if this shows up on the screen. Well, it did not, so I'm going to have to put that in a little bit later, but we'll have a calculator here to the side. So as we take a look at this one, we were told in the instructions that a computer chip has a thickness of 0.32. It's made up of layers of silicone on the top and bottom. Each have a layer of 0.03. So obviously it only has one top and one bottom. So we will label those. The bottom is going to consist of 0.03 and the top is going to consist of 0.03. So of our 0.32, we've accounted for 0.06. And then it says a inner layer consists of 0.02 centimeters each. How many layers will there be in the middle? So we had 32. 0.06 is on the outside, which means we have 0.26. Since each of those have a measure of 0.02, we can divide this by 0.02. And our result is going to be 13. Do make sure that you read this because it does say how many inner layers. This is the type of question they could easily have said how many total layers. So make sure that you read anytime you're doing these. Okay, as we read, in the figure below, C is the intersection of AD and BE. We can see that happening here. If it can be determined, what is the measure of BAC? So make sure you label the angle that you're looking for before you go here. You are going to see what's known as, if you recall from Algebra 2, vertical angles. Anytime two lines intersect, the angles on opposite sides of the vertex are equal. They're called vertical angles. So since this angle is 45, this angle is 45. And then we also have the sum of interior angles of a triangle. We should all know that's 180 degrees. So BAC is the third angle of this triangle. So we subtract our 35, which we know, and we subtract our 45, which we know. Those combine to equal 80. So when we subtract that away, we have 100 degrees left for our missing angle. Sometimes on these, it's best to just look at the last sentence and read, because the first few sentences are just describing what you see in the picture. So what we have here is the last sentence says, what is the degree of the measure of angle A in terms of x? So we're talking about angle A right here. Now let's talk about some of these answers first of all. C is saying that it is 180 plus. That's a straight line is 180. So that would be more than 180. And so would H. So make sure we get rid of answers that don't make sense. Those can't be the case. So we know that this is a trapezoid that says that this side is parallel to this side. On a trapezoid, you can also know that this angle that are between the parallel lines, they're not equal unless it is a rectangular shape, square shape. So we know that this is also not x. But what we need to know is that when we have parallel lines, these are what's called consecutive interior angles, are supplementary, which means they add up to be 180 degrees. So x plus our angle A, which we do not know, should combine to equal 180 degrees. So in order to get the angle by itself, we subtract x, and we learn that angle A would be 180 degrees minus x. That would be our answer F. I'm going to again start by identifying the last sentence, what I'm looking for. What is the measure of CAD? So we're looking at angle CAD. CAD is part of a right angle. Our x value can be negative, but likely not going to be on this because this was negative 20 here. So again, use your common sense on some of this. 160 degrees plus x. Yes, our x could be negative, but the amount of negative that it would take to get it here would make this a negative angle, which it's clearly not. So what we have is angle BAC, label this one in blue, has a measure of x plus 20. We are looking for angle CAD. Together, these are what's known as complementary angles. Complementary angles add up to be 180 degrees. So angle BAC, we know to be x plus 20. Angle CAD, we're looking for. But according to our figure, we know that they equal 90 degrees. So I'm going to, just like a variable, I'm going to solve for this angle CAD. Well, the first thing I need to do is subtract 20 from both sides. Takes me down to 70. So angle CAD x plus angle CAD is equal to 70. So we just last need to subtract our x. And what we learn is angle CAD is equal to 70 minus x. Angle G, or answer G. All right, I'm going to show you this one first of all. It's just best to know how to do things. This is an isosceles right triangle. It says so right here. Isosceles right triangle. And it says the hypotenuse is 8 times the square root of 2. Well, if you remember from your geometry days, when you have an isosceles right triangle, the hypotenuse is the other sides times the square root of 2. So they gave us a gift here, and these sides are both 8. So we are looking for the perimeter. Make sure you always look what you're looking for. So the perimeter would be 8 plus 8, which is 16, plus 8 square root of 2. So that took us, even with describing, 40 seconds. Knowing how to do it is always a major advantage. But let's just talk about some general stuff here. Just recognizing, first of all, it says the perimeter of the triangle. I'm going to go ahead and put what these numbers are. 8 times the square root of 2 is equal to 11.3, approximately. So clearly the perimeter is not going to be less than the hypotenuse. That's answers out of the argument here. But we also need to remember that the sides of the triangle have to be the two smaller sides, regardless of the shape of the triangle, whatever this side is, and this side have to be greater than the largest side. So I know, let's just call this angle A, side A, and this side B. I should have used lowercase letters, sorry. So we'll call this A and that B. We know that A plus B has to be greater than 11.3. Has to be greater than 11.3 because it has to be bigger than the hypotenuse. So we know we have to have a number greater than 22.6. So as we look at these answers, the bare minimum, these are going to be 11.6. They got to be bigger than that. Well, 16 is lower than that. I just put it in my calculator. 8 plus the square root of 8 plus 8 square root of 2 is equal to 19. Doesn't matter. It's too small. And then if we put into our calculator 8 plus 16 square root 2, it does come out to 30. So that's at least a viable answer. But there are only two viable answers here. This comes out to 30 point something. And then 16. I know it's the right answer, but we still need to put it in our calculator. It should not come out to exactly 22. So this one ends up being about 27. So if we just remember those rules of triangle like we talked about, there's really only two answers that are even a possibility. So we're down to that. And if you look at the pattern, you can obviously, the 8 square root of 2 is a more common pattern with the 16. Just keep that in mind. Those rules of triangles, they'll at least get rid of answers for you, but sometimes they'll just straight up give them to you. All right, first thing I want to point out on this, we're dealing with the trig ratios. And remember, the trig ratios of sine and cosine have to have the denominator of the hypotenuse. So when we look at these last two answers, the denominator is smaller than the numerator. So these are not even a possibility. You cannot have a trig function where the sine or cosine where the um, denominator is not bigger. As we look at the figure here, and again, our figure tells us what we need. You can go through and read all of these things. Just read the last sentence, make sure that you have what you're supposed to have. So it says, solving this, which equation gives the measure of theta formed by the slant height. Don't worry about the terms that you don't know. A slant height is just the height going down this way here of the cone and the radius. So one thing we talked about as well is anytime you're missing the hypotenuse, which we are in this case, you know you're going to be using tangent. So sine is out of the picture as well. So we know we have tangent. Tangent from this angle is opposite, which is 7. There's our answer. So we're ready to move on. But it is 7/5. I also want to take a look at one other thing on these. We have already established that these last two answers can even work. I actually went through my calculator, made sure my calculator was in degree mode, and I did the inverse tan to solve for this. So inverse of 5/7 comes out to an angle measurement of 35 degrees. I did inverse tan of the 7/5, which of course was our correct answer. It came out to a measure of essentially 54 degrees. And then I even did the sine because it was not a throwaway answer, but the sine of 5/7 came out to essentially 45-degree angle. It was 45 and some change, 45.6 essentially. So let's think about our other rules of a triangle. The larger the angle, the larger the opposite side. If these two angles were equal, that would be, or if the two sides were equal, they would both be 45-degree angles. So these sides are definitely not equal, so sine's out of the picture. Now, as we look at this, they are not equal, so if they were equal, it'd be 45. Since this is opposite of the larger side, that means our angle has to be greater than 45. Well, this answer is below 45. This answer is greater than 45. So we could have even gotten this by setting it up either ways. And a matter of fact, this angle that's up here is the one that's 35. Just keep those things in mind, then maybe that can help you as well. Okay, as we take a look at this is the 3 questions in one. We're looking for the slope of segment CD. Well, as we move from left to right, that is a negative slope, so these answers are off the board. Now, generally speaking, the answer that remains, the one that has the opposite, like C as B, is generally the right answer, but let's get verification of that. We know it's none of those 3. We either know it's down 3/1 or down 1/1. They're trying to get you, because if you do go down 3, you go from 4 to 1, it does move you down this line. But don't forget, -3 is rise or run, rise or drop in this case, -3 and run 1. Well, we didn't run 1. That would put us right there. We ran 3/3. And the formula, which is -1. So the formula we use is y2 minus y1 over x2 minus x1. That is your slope formula. So as we take a look at this, again, this is part of the last one. What we see is in figure ABC, the reflection across over the y-axis. What you need to remember is anytime you're dealing with axes, that it affects the other coordinates. So when we go across the x-axis, the effect is actually on the y-axis, excuse me. The effect is on the x value, and this tells us that it is a reflection. Reflection is just a sign change. So we're going to identify where D is. It's at 12, 12/1. So when it's a reflection across the y-axis, only the x value will change. That would be this. So our answer would be answer F. Now, if it was a reflection across the x-axis, you change just the y. And if it's a reflection across the origin, you change both. This one's a little tricky. So what we are told in this, it says, which of the following vertical lines cuts figure ABC into 2 trapezoids with equal areas? Instead of checking and guessing these things, what you want to do is recognize that they both have triangles of unequal sides, but the triangles do have the same height. This would be the change in y. So this triangle has a height of 3, so does this one. This triangle has a base of 3 because we went from 9 to 12, and this triangle only has a base of 1. So if we were going to find the area of these triangles, we'd go 1/2 base times height for the one on the left and 1/2 base times height on the other one. So we learned that this one has an area of 1.5 when we put that in our calculator, and this one has an area of 4.5. So there's a difference of 3. So when we break down this rectangle, we need to take a look at this. So first of all, this rectangle has a side of 6. This is actually, we can go to these answers real quick and see, since this triangle right here is smaller than this one, we need to give more of the rectangle to the smaller side. So when I drop this thing in here, right in the middle of 3 and 9 is actually a measurement of 6. In this case, it would be 6/4. Well, we know we have to tip the scale towards the small guy. We got to give it a little bit bigger piece. So we know that the x value's got to be higher than 6. All of these other answers are lower. So the only one that can work here is 6.5. But what you would do on this is you would, let's say the answers were not so cut and dry. We need to cut this rectangle where 3 more goes to the smaller than the larger. Well, the rectangles we're going to draw when we split them will have a height of 3, and then the width of those things are going to be determined. So we just make sure that when we're done with the triangle, that the triangle attached to the smaller, or excuse me, the rectangle that's attached to the smaller triangle does make up the area of 3. All right, so as we take a look at this one, it says point E is at 6,4, point F is at 412, line in a standard XY coordinate planes shown below. So again, a lot of times those first sentences just tell you what you see. It says point D lies somewhere on this line. Somewhere on this line between E and F, such that EF, that's the whole thing, from here to here, is 4 times, and please write on your test like I'm writing on mine. All right, it's just a good habit to get into. Helps your mind process it a little bit better. So it says the length of EF is 4 times the length of DE. So DE is clearly the smallest, and that also means, since it's smaller and we're going from E, D is going to be closer to E than it is to F. Keep that in mind as you go through here, because some of these answers just don't work. K is closer to F, and so is J. So those answers are not even viable answers on this. Now this actually works really good because 4 times allows us to split it 4 ways. Here, 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 and here. So those are 4 segments. This segment is 1/4 of the other one because the other one is 4 times as long. Times 2 would be here, times 3, times 4. So we lucked out because this is actually the midpoint of the midpoint. So all we've got to do is find the midpoint of this. Well, the midpoint of 6 and 14 would be 10. That's 16 plus 14 plus 6 divided by 2, that's 10. So, and the midpoint of 12 and 8, well, that'd be 12 plus 4, would be 16. So the midpoint of that is 8. Okay, well, that's the midpoint. We need to find the midpoint of the midpoint. So the midpoint between 6 and 10, of course, is 8. They're only 4 units apart. And the midpoint between 4 and 8 is 6. So this would give us a segment that is 1/4 the size of the others. So in this particular one, we were able to just bypass the distance formula. So as we look at this, we probably didn't spend a lot of time in geometry working on this, but we have a couple of things that we can highlight on this, and it's generally going to get you down to your answer. First of all, it asks us which system is represented in this inequality. So first of all, let's look at this line. This line is y equal to -x plus 2. As I look at E, I don't see anything that those have to do with the two lines in the circle that we're given here. So that's not a possibility. So we know this about lines. This is a line, y-intercept of 2, slope of -1, that's all great. But on this line, let's forget the circle for just a minute. We have shaded in this section below the line. And below is always a less than sign. So we have a less than sign here, so that one could work. This one's a greater than sign, so the whole answer is out. This is a greater than sign, and the whole answer is out. So just by knowing about lines, we're down to 50-50 on this thing. Now, here's what you need to know about circles. Circles, it's not above or below, it's within or outside of. And if you think about it, are you less than the circle or are you greater than the circle? Well, I think it kind of makes sense that greater than the circle is everything on the outside, less than the circle is everything on the inside. So we have definitely shaded inside of the circle, so we're looking for a less than sign. This is a greater than sign. So this answer does not work. So the only answer left is A. And by the way, if you ever get lost, a great idea is to plug in the origin. If I were to plug in the origin to this, well, that would be 0 minus 1. That's -1 squared is 1. Put in 0 here, -2 squared is 4. And 5, 1 plus 4 is 5, is definitely less than 9. And down here, it would have said 5 is greater than 9. So anytime you have shading, you can always check an answer, and it always makes sense to check that origin. That origin is so easy to plug in. And you could plug it into the first one as well, but I think we've got a better understanding of a line, and that's not necessary. And by the way, if the origin was not shaded, I still would use the origin to look for a false statement, because I knew I was down to 2, remember? All right, so I really like this one, which usually means you're not going to like it, but give it a shot. Give it a shot, see what it looks like. First thing I'm going to do is read. It says, you can find the volume of an irregular shape solid object by completely submerging it in water and calculating the volume of water the object displaces. Now that doesn't matter anymore. I won't read it again. You completely submerge a solid figure into a rectangular tank that has a base of 40 centimeters. So this is three-dimensional, and it has 40 by 30. So we'll call it this 40. We'll call this 30. So this side's 40 and this side's 30. So we have a rectangular shape, 40 by 30, filled to a depth of 20. So this shape is going to be 20 units tall. Go outside there. So this is the shape that we're looking at. 30 by 40, that's the top. 40 is referring to that. The object sinks to the bottom and the water level goes up 0.25 centimeters. What is the volume of the cube? So the water level right now is at 20. So we can do this one of two ways. We can either look at the excess as this goes up, or we could draw the figure again. Well, the new figure is going to still have a width of 30, height of 40, however you want to call it. This is still going to be the same. This is still going to be 40. This is still going to be 30. But now our height is no longer 20, but 20.25, because it told us it got 1/4 of a centimeter more in depth. So now ours looks this way. So that's one way we could do this. And if we calculate the volume, I'm just going to go ahead and put these in my calculator. Remember, volume is length times width times height. So length times width times height, this has a volume of 24,000. And this one, length times width times height, has a volume of 24,300. So we can see that the volume increased by 300. Now I said you could just do the excess as well. Well, this little shape right here, if I were to shave off the top that we added, well, that's still 30 by 40. 30 by 40, but its height is a mere 0.25. Oops, a little off on my picture there. But it's a mere 0.25. So we would go length times width times height, and that would give us 300. It really doesn't matter which way you do it, just however your brain works, go with that. All right, this one it says, formula for surface area of a rectangular solid is shown right here. Thanks for the formula. We'll be using that. All right, where L is the length, W is the width, H is the height. By doubling each of the dimensions, length, width, and height, the surface area, not volume, the surface area will be multiplied by what factor? Well, hopefully you got a good memory. If you've got a good memory, this is a real easy question. Just think of it this way. The area is two-dimensional and the volume is three-dimensional. So whatever the multiplier is, these are the powers that you use. So by doubling each dimension, double is 2, and it's a area, two-dimensional, it's 2 squared. So the factor that we're going to see is 4 times as much. So our answer is B. Had this said volume and it said double, we would have done 2 to the third power and it would have gone up 8, a factor of 8. All right, you got a good memory, great, you can use that and go with it. If you don't, my suggestion would be to give these dimensions actual numbers and see what happens. I love the number 3. Those that are in my class know this. 3, 4, and 5. So if I go to these formulas and plug in 3, 4, 5, so that would be 2 times, let's call this the length, the width, and the height. 2 times 3 times 4 plus 2 times 3 times 5 plus 2 times 4 times 5. If I put all this in my calculator, which I definitely would do, this comes out to 94. Now these values don't mean anything on this. We're just creating our values because it asks us for the factor, the multiplying factor. So now it said double all of those sides. Okay, well, the 3 becomes a 6. The 4 becomes an 8. Move to the next one. The 3 becomes a 6. And remember, I'm not doubling the 2 because it said we doubled the length, width, and height. So I'm just doubling the length, width, and height. This becomes 10. This becomes 8. And this becomes 10. Well, when I put all of this in my calculator, what I get is 376. So if it's true, it should be true on every single number. So me generating these numbers works out fine. And if I do 376 divided by 94, I get 4. Obviously, memorizing this little geometric fact is the best way to do it. But if you get stuck, again, that took a little bit of time. But for some of you, that time investment is worth it. All right, correct answer.